Good morning, children. Here we are today with some numericals on chemical equilibrium. We know that for this equilibrium, suppose A plus B reversible C plus D, equilibrium constant C is equal to molar concentration of C, molar concentration of D by molar concentration of A, molar concentration of B. And if the equation is like this, then we know we have Kc equal to molar concentration of C raised to the power C, molar concentration of D raised to the power D by molar concentration of A raised to the power A, molar concentration of B raised to the power B. Okay, and same thing if for gaseous system, we can also express in terms of Kp, and Kp means partial pressure of C, partial pressure of D by partial pressure of A into partial pressure of B. So this is what we have got. Now numericals on this. First of all, I would like to give you a concept that will help you in solving numericals on chemical equilibrium. Suppose we have a system, say A plus B reversible C, and at start, suppose when we want to attain this equilibrium, so we are starting with A and B, and at the beginning C is not there, and suppose we have at the beginning we had taken 1 mole of A and 1 mole of B, and at equilibrium we start with 1 mole of A and 1 mole of B, and say after some reaction has happened, then equilibrium will be attained. Suppose X is the amount of mole of A reacted. X is the amount of mole of A that has reacted, and then equilibrium is attained. X of course is less than 1. So if from 1 mole X mole has reacted, then left over will be 1 minus X. So moles of A at equilibrium will be 1 minus X. Similarly, moles of B also will be 1 minus X. And since X mole of A has reacted, X mole of B has reacted, then X mole of C will be produced. Because 1 mole of A, we can see, has reacted with 1 mole of B and forms 1 mole of C. So if X mole of A has reacted, X mole of C will be produced. So this is the moles of reactant and products at equilibrium. So this is this you need to understand. Now suppose we are considering this equilibrium, say A plus 2B reversible, say C. This is C. Suppose this is equilibrium now, and here say at start say we have once again say 1 mole of A, we have 1 mole of B, and C there will be nothing at the beginning, and say at equilibrium what will be the moles of reactant and product is suppose X mole of C is produced at equilibrium. X mole of C is produced at equilibrium. Suppose x mole of C is produced at equilibrium. Now since we see from the equation 1 mole of A reacts with 2 mole of B, forms 1 mole of C, and if x mole of C is produced, so definitely x mole of A has reacted. X mole of A has reacted. So after reaction, or when equilibrium is attained, moles of A left will be 1 minus x. 1 minus x. And what will be amount of B left? No? Here you see 1 mole reacts with 2 mole. So if x mole of A has reacted, 2x of B will be reacting. 2x of B will react. So 1 minus 2x will be here. 1 minus 2x. This will be the moles of B at equilibrium. Okay, this is very important to understand, because if you understand this thing, then you won't have any problem in solving numericals on chemical equilibrium. So, when x mole of C is produced, then x mole of A has reacted, and 2x mole of B will be reacting, so that moles of A left will be 1 minus x, moles of B left will be 1 minus 2x. So this is you need to understand. Now sometimes so let us consider another situation. Another situation is, suppose we have suppose 2a plus 3b arrow C. Suppose we have this situation. This is an equilibrium, and say at the beginning, that is at start we have in the system, say 5 moles of A, we have 5 moles of B. Now suppose, now let me take here this one again, a different amount. Suppose we have 6 moles of B, and initially there won't be anything at the product. Now at equilibrium, what will be the concentration of all these things left that we have to do? Suppose 2 moles of A has reacted. Suppose 2 moles of A has reacted. So A left will be 5 minus 2, that is 3. 3 moles of A will be left. Now, if 2 moles of A has reacted, then how much mole of B will react? If 2 moles of A has reacted, 3 moles of B will react. So, moles of B left will be 6 minus 3, that is 3. Now, how much mole of C will be produced? How much mole of C will be produced? Now, as it is said, shown, 2 moles of A react to form 1 mole of C. If 2 of A has reacted, so 1 mole of C will be produced. So, moles at equilibrium will be 3, 3, 1. So, this concept you should have. Let us now do some numericals. Okay, first of all, we will do some NCERT question. So let us do NCERT. So let us do first question number 9, 7.9 of NCERT book. 7.9. So it says that we have this equilibrium in this question: 2NO gaseous plus Br2 gaseous reversible, 2NO Br gaseous. So according to the question, it is saying at start or at beginning they are starting with 0.087 moles of NO and 0.0437 moles of Br2. This is what at the start they are taking. So at the start, product will not be there, so let us put it dash. And in the question it is given at equilibrium they are saying that 0.0518 moles of NOBr is obtained at equilibrium. Then we have to find out equilibrium amount of NO, equilibrium amount of Br2 when this much amount of NOBr is produced. So this is a question. Okay, now we see from the balanced chemical equation 2 moles of NO produces 2 moles of NOBr. Now if this much mole of NOBr is produced, certainly this much of NO has reacted. This much of NO has reacted. So moles of NO left will be 0.087, the starting one, minus this much, 0.0518. So if you subtract, then you get this answer. And what about this one? This one, you see when 2 moles of NO reacts, then 1 mole of Br2 reacts. So moles of Br2 left will be 0.0437 minus half of 0.0518. So this, on simplifying, you get the answer. Now we will do another question. Okay, now let us do 7.11. Question number 7.11. It says that, okay, now this is about this equilibrium: 2HI gaseous, reversible, H2 gaseous plus I2 gaseous. So what they are saying that the pressure of the flask pressure of the flask, which has this one. Pressure of the flask initially is 2 atmosphere, sorry, 0.2 atmosphere. So that means at start, we can write the pressure of HI is 0.2 atmosphere. At the beginning, H2 and I2 is not there. So whatever pressure this flask will exert will be due to HI. Okay. And then they are saying that at equilibrium the partial pressure of HI is 0.04. At equilibrium it is 0.04 atmosphere. So you see it has reduced because some amount of HI has reacted, so its pressure is going to decrease. What is the Kp for the equilibrium? They are asking now to find Kp. We have to find Kp. So before we find Kp, we have to know the amount of H2 and I2 at equilibrium. Now we have to first find out how much HI has reacted. How much HI has reacted, we have to find out. And that we can find out by the difference. So HI that has reacted will be 0.2 minus 0.04. So subtracting it will be 6 and here it will be 1. So 0.16 atmosphere, this much amount of HI has reacted. Now if 2 moles reacts to form 1 mole of this, 2 moles form 1 mole of this, and if 0.16 mole of HI has reacted, so pressure of H2 will be 0.16 divided by 2. Similarly for I2 also it will be 0.16 divided by 2. So this value will be 0.08. This value also will be 0.08. So we have at equilibrium HI 0.04 atmosphere, H2 0.08 atmosphere, I2 0.08 atmosphere. So now Kp, we have to find Kp expression will be partial pressure of H2 into partial pressure of I2 by partial pressure of HI to the power 2, product by reactant. Now we put these values here, it is 0.08 into 0.08 by 0.16 square. So you simplify this, you get the answer. Okay. Now let me tell you one thing here, we don't need to write any unit for Kp or Kc. Okay, we don't write, just the value we will write. So now one final numerical for today that I am going to do is, now let me do one question on Kc. One question related to Kc. That is question number 14, 7.14. So it says that it is about this equilibrium. You will see H2O gas plus CO gas reversible, H2 gas plus CO2 gas, and it says that at start we have 1 mole of water, 1 mole of carbon monoxide, it says, and this is we have in this reaction taking place in 10 liter flask. Volume of the flask is 10 liter. And this reaction is happening at 725 Kelvin. And it says that at equilibrium 40% of water reacts. 40% reacts. It says 40% of water reacts. So then we have to find Kc. So straight away we can say if starting water is 1 mole, if 40% has reacted, means 40 by 100 is 0.4. So 0.4 has reacted. 0.4 has reacted. So at equilibrium, moles of water left will be 1 minus 0.4. That is 0.6 moles of water will be left at equilibrium. Similarly, since 1 mole of water reacts with 1 mole of carbon monoxide, same thing will be for this one also. 1 minus 0.4 will be 0.6 moles of CO will be left behind. And moles of this will be 0.4, 0.4. So these are the moles. And now suppose Kc expression, Kc expression will be molar concentration of H2, molar concentration of CO2 by molar concentration of water by molar concentration of CO. This molar concentration, is moles by volume. So molar concentration of each of this, will be 0.6 by volume of the flask. 10. Molar concentration of this will be moles by volume of the flask. All of them will have volume 10. So 0.4 by 10. 0.4 by 10. So these are molar concentration. This we have to put. So 0.6 by 10 into 0.4 by 10 into 0.4 by 10. And reaction 0.6 by 10 into 0.6 by 10. So this one will be the Kc value, and 10 will all get cancelled, so it will be 0.4 into 0.4 by 0.6 into 0.6, and so it will be just so if you simplify, you get the answer of Kc. So children, this much we will do for today. You should do other numericals given in NCERT book. So bye bye for now.